Hi, I spent the New Year countdown in the dark because there was a power outage and half the city was out. I finally thought of a solution though, but 2016 was already gone. See, I have this power inverter for use in a car. You connect it to your cigarette lighter or directly to the 12-volt battery and it generates AC output, so you can use it to power your stuff at home. You can't drive your car into your home, but you might have a battery-operated drill that runs on a 12-volt or 14-volt battery. Then you're set. Let's connect it up. Oop, I probably connected backwards. My luck is I never connected right the first time. No, it doesn't work? Are you kidding me? Not only it's completely broken, its 50 amp fuse is blown. Who designed this shit? Reverse polarity protection relying on a 50 amp fuse to blow? Seriously? It's like cutting your dick to prevent pregnancy. I replaced the fuse and now if I connect my Mushy multimeter to the input terminals of the inverter in reverse, I can clearly see that there is a diode drop voltage across the terminals. This is the circuit they have. If we connect the battery here, the current goes through the fuse here and powers the circuit here. But if we connect the battery backwards like this, then the diode forward biases and there is a huge current through the fuse that blows the fuse and it can't even protect the circuit here. Even their data sheet says reverse polarity connection will result in a blown fuse and may cause permanent damage to the inverter. Absolute garbage. Well, this is bullshit. Now I have to buy a new inverter. This wasn't even the focus. Okay, let's see. Is there anything on sale? Let me test a couple of these and see if it has the same crap circuit. Huh, this one has a diode drop too. Wow, even the cat has the same crappy protection. Seems like the same person designed all of them. I'll just get the cheapest one. Dear inverter designers, this is the circuit you need. Keep your fuse, change your diode to a TVS diode and use a MOSFET in this configuration for reverse polarity protection. Anyway, I have my drill battery and I have hooked up my Mushy meter so we can measure the current and voltage on my phone. Now we connect the battery and turn on the inverter. Here we go. We have around 5 amps from the battery at 12 volt which draws 60 watts from the battery. This is good but it drains my puny drill battery quickly. So instead I can use an LED light and you see it only draws 1 amp or 12 watts from the battery. So this is gonna last much longer and provides the same brightness. Now I like to plug my inverter into the outlet of my house so I can power more things. And for that I made this harness that you can plug to both sides. First you plug it to the inverter. Anytime you connect a power harness, connect it to your load side first so you wouldn't short your power supply or shock yourself. I'm only human after all. This is probably the most stupid harness one can make because it exposes high voltage on both sides, so don't make it. Let's very carefully plug it in. Yes, we have to make sure our load is not powered from a different source, like the city power. The issue is that although both these sources are 120 volt AC, they are different in many ways. The yellow sine wave is the city voltage and the green wave is the output of the inverter. You can see that they don't have the same shape, they are not in phase or even have the same frequency, so connecting them together shorts their voltages badly. So in order for me to power a room from a plug, I have to disconnect the main power and some heavy loads like the washer and the fridge because my inverter cannot take that much power. Actually, that's pretty dumb. It's better and easier if I just disconnect that specific room, which I believe is breaker number 3. Now we can safely plug them in. Apparently it was breaker number 2. Always make sure you open the correct breaker by connecting a light or something into the plug. But here's a redneck way of knowing which one is the correct breaker. Just short the plug in question and the correct breaker opens. Don't do it. One last try. There, it's working. 2 lights, my phone, all working. One thing you should realize is that your phone line or internet doesn't disconnect when there is a power outage. So this way you can bring them back. Oh, now my inverter is complaining. The problem is that my puny drill battery can't last for long. But if you have one of these larger batteries, like this one for example, that has 7.2 amp hours, it will last for much longer. Let's turn on the TV by my inverter and measure the current. It is drawing 16 amps from 12 volts, so it is around 200 watts. My battery is 7.2 amp hours and drawing 16 amps from it will shorten its life quicker. We need a car battery. With this, I plug the entire setup into my inverter. The TV, digital box, my phone, the radio, and even the light. The setup is drawing around 22 amps from the battery, and my battery is around 75 amp hours, which means it will last for more than 3 hours. So I'm set. Okay, let's return the battery. Let's try it. You know, there are these things called UPS or uninterruptible power supply that output AC, have their own battery and charge it too. Maybe they are worth the investment.
Giveaway time!
You know, this Mushimeter has become increasingly handy. It would be a shame if I had to give it away. Yes, I'm giving away 10 Mushimeters to my patrons at patreon.com, no matter what Mushi means in German. You can also buy it from these sources. And you know, I want to make some secret videos that I don't want everyone to see available to my patrons. Hopefully that's a good idea.